these two different techniques when we have the unknowns, if it is in the term of some other function. See, this is what the x is a function of g. Then it is very hard to find the results with the direct method and iterative method. So we need to depend some other technique to find the result. That is here. Here the method we are going to deal with phenomena is Newton-Rapson iteration method. So if the x n plus 1 is equal to g of n or g of x of n or f of x of n, so that will find the solution of every equations using iterative and the direct method is not feasible. So other iterative method that is useful we are going to have a visit is Newton-Rapson method. And let we want to find an approximate solution for an equation function of x is equal to 0. Assume a function of x is equal to 0. Let this be the function of x, that is y is equal to x cube minus x minus 1. And what we need to do first, we need to assign some particular values for x. Let we begin with 0. If yx is equal to 0, what would be the y? If x is equal to 1, what would be the y? So by doing so, what we can get a number of data. As well, in the negative order also we need to put, and we can make a diagram, so that this is what the diagram which you studied during your school days. And see the results falls between, this is what the results zone, right? While doing getting the graph for this particular function. Anyway, I'll tell you how these type of graph can be drawn with the aid of Excel. I'll tell you a little later. See, the results for the results lies between 1 and 2. The function takes the changes the sign conversion between 1 and 2. So the results fall between 1 and 2. What we can do, that is what the Newton-Rapson method detailing. The root alpha lies, let the root might be alpha. So the root alpha lies between 1 and 2. This is what our alpha. What we need to do, we need to make a move towards alpha in order to find the results. So we'll track and we will find the result. This is what alpha, right? This is what the alpha. And yes.
So the slide is not updated.
Still?
No, sir, I'm not seeing that alpha.
Yes. Now?
It is visible, sir. Alpha in graph.
Yes. Yes, alpha lies between 1 and 2. It is visible. See, now check whether it is visible.
Yes, sir.
Yes, sir. Now
yes. Okay. What we are going to do, we are going to zoom it the particular zone which has the root. So this is what our results. Rapson suggestion. This was the first estimate. So we will begin with the known boundaries, that is 1 and 2 would be known boundaries. So let's start 2. This is what our x naught. You try to draw the tangent for the curve. This is what the curve y is equal to f of x. So try to draw the tangent to the curve at x naught. This is what so no, this is what the x naught line which meets the y. Here what we need to, where the x naught meets the curve, at that particular point we need to make a tangent. This is what the tangent. What tangent does, or what tangents, why we depends on tangent. We moved from x naught, that is 2 to somewhere near we can make a move from x naught to alpha, x naught to alpha. That is what our objective. See, the point where the tangent meets the x-axis, we call x1. This would be the x1. And repeating the same procedure, that is, try to draw the vertical line to the function of x, and then again try to draw the tangent. What you will get, you will get a nearer solutions than x1. So this is what the x2 is. Each point, that is x1, x2, is closer to alpha when compared to x naught. That is what the Newton-Rapson suggestion. So to carry out the iteration, we need to find the points where the tangents meet the x-axis. So this is what the point, that is x naught and y naught. And so what we are going to do, the gradient of the tangent, we are going to find the solution. We are going to approach the alpha value with these physical phenomena, with these principles, with these mathematical calculation. The gradient of the tangent is equal to the change in y, right? We know the tan theta, we know the tan theta, change in y, and the change in x, right? The change in y and the change in x. The tan theta is equal to opposite by adjacent. So the change in y divided by change in x. So this is what our change in y, that is y naught. This is what our change in x, that is x naught minus x1. So we are going to apply this instead of the change in y and change in x. Therefore, that is here, instead of the gradient, that the LHS is transferred into dy by dx. Dy by dx is then the differentiations with the function at x naught is equal to y naught divided by x naught minus x1. So we have dy by dx, that is x naught is equal to y naught by x naught minus x1, and we need to find the value of x1. So our ultimate objective is to find the alpha value, that is the appropriate results. So further repeating or further continuing this things, that is using y naught and dy by dx at x naught in the formula is not very convenient. So let the y is equal to f of x. We have y naught, instead of y, I am going to apply with y naught, and instead of f of x, we are going to apply with f of x naught, and therefore dy by dx x naught is equal to y naught divided by x naught minus x1 be the f dash of x. If it is y is equal to f of x, and this is what dy by dx, so this can be the f dash of x, right? The given function of y is an initial condition. By doing the differentiation with that, we can make it, this RHS would be the f of f dash of x, that is known, that is usual. So f dash of x is equal to, instead of y naught, I am applying f of x naught divided by x naught minus x1. So my objective is to find x1. So I am trying to find the x1 value by making some mathematical rearrangements. So x naught minus x1 is equal to f of x naught divided by this f dash of x naught begin to the we can make it into RHS, and by continuing this, I can make x1 is equal to, this x1 can be taken into the RHS, and this term can be taken to the LHS. So x1 would be x naught minus f of x naught divided by f dash of x naught. This is what our essential equation in order to find the newer x value. So x1 is equal to x naught minus f of x naught divided by f dash of x naught. But the thing is, the subscript, by continuing this, what we can do, what we can get, x2 would be x1 minus f of x1 divided by f dash x1. So in order to make it a general, and what we can do, instead 1 I can apply n. So my x n plus 1 is equal to xn minus f of xn divided by f dash of xn. This is what the equation, this is what the suggestion by Newton-Rapson for getting the results of when we have the equation in terms of functions. So this is what our formula Newton-Rapson suggestion, that is f of xn, sorry, n plus 1 is equal to xn minus f of xn divided by f dash of xn. So hope you have noted everything, and we do not need diagram to use this formula, but we must know how differentiate. So differentiation and integration basic formulas are essential to carry out these Newton-Rapson method. The convergence. So all the time making the diagram would not be feasible, but with these formulas we can find the results. And convergence also, where the convergence rate also very much essentials. This is what your example 1, and before that you take your calculator. You will refresh
Sir,
the differentiation and integration formulas. Yes.
sir, can you go to previous slide, sir, for one second?
Yes, this is what your required slide.
Yes, yes. I just need to copy one, sir.
Yes, someone you please unmute your mic and refresh the differentiation formulas. You begin with x power n, e power x, e power ax, sin x, cos x, and so on.
Thanks.
Yes. Someone, you please make it fast. Make it fast. Xavier. Joshua Xavier. Yes, you please unmute your mic.
Okay.
Yes. What is exponent? Differentiation formula. What is exponent?
Differentiation of x power is equal to n into x power n minus 1. Sir.
Okay. Then e power x. Tell me
E
the
power
answers.
x. Differentiation of
answer.
e power x. E power x.
E power x.
E power x. E power a into e power a. Sir.
E power ax. Okay. Sin x.
Differentiation of cos x.
Cos x.
Minus sin x.
Sin ax.
Sorry, sir.
Sin ax. Sin
Sir,
ax.
sin a into cos a. Cos a.
Very good. Sin cos ax.
Minus a into cos a.
Very good. Nabil. Thank you, Xavier. Nabil, you please unmute your mic, Nabil. Nabil.
Yes, sir.
Yes. The same formulas with integration. E per x per n.
X power n plus 1 by n plus 1.
E per x.
E power x, sir.
E per x.
E power ax by a.
Very good. Sin x.
Cos x.
Minus cos x.
Minus cos x, sorry.
Okay. Cos x.
Sin x.
Sin x.
Minus cos ax by a.
Very good. Cos x.
Sin ax by a.
Very good. This is what the basic formulas. We will refresh the. Thank you, Nabil. We will refresh the other formulas in the subsequent class. You keep your decimal places into 4. Take your calculator. Take your calculator. Keep your decimal places into 4. Kabilan. Kabilan. Kabilan, you are going to answer. Yes. This example 1. I am going to depend you to get the answer, Kabilan. You keep your decimal places into 4, Kabilan. Okay, are you ready, Kabilan?
Okay, sir.
Yes, see, it is a very simple mathematical calculations, and see what we are going to do. This is what the given function. Use the Newton-Rapson method with x naught is equal to find the root of the equation x cube minus x minus 1 is equal to 0. Correct to 4 decimal places. So we need to consider this as a function of x. So this is what the function of x. Let the function of x be the x cube minus x minus 1. In order to apply with f dash of x, we need to get f dash of x, right? So f dash of x is equal to, as the formula stated by your friends, x cube 3x square minus x become 1, 1 becomes 0. So this is what your f dash of x. So this is what our formula, right? Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. And I am applying these informations, that is xn. What is my xn? This is what xn alone minus xn power 3 minus xn minus 1 divided by f dash of x. F dash of x. My f dash of x is 3x square minus 1, right? What you are going to do? So you take your calculator, apply these information. Earlier you give 2 and give enter. Kabilan. Kabilan.
Yes.
Yes. Yes. You please give enter and 2 and give enter.
Sir, I have actually just ordered for the calculators that will be arriving just this week. So, this is something I can like calculate using pen and paper, sir.
Pen and paper it would take a longer time. See, Kabilan, we are in the 10th class. Make it.
Yes, sir, I have ordered for it, sir. I'll be getting it by this weekend, sir.
No issues, but making some other arrangements would be better, right? Getting
Yes,
from your friends. Anyway, right, we'll depend some other one. And Nishant, Nishant, you unmute your mic, Nishant. Okay, Nishant.
Yes, yes, sir.
Are you having your calculator?
Sir, no, sir.
No.
Yes, sir.
So this is what the negligence of duty, dear gentlemen. See, you are doing your numerical methods without calculator. How it is feasible to get the information? How it would be feasible to practice with these mathematical calculations? Anyway, anyway, it won't be good. You make as early to get the calculator.
Yes,
And
sir.
Sai Teja, Sai Teja,
Yes, sir.
yes. Are you having your calculator?
Sir.
Are you having your calculator? Teja, you please unmute your mic. See, I am keeping this order. So what happened? Sai Ranga left. Once if Sanjay, sorry, Sai Teja won't feasible to get the results, I'll approach Pranav. If I am approaching Pranav is also refusing, I'll approach Sanjay. Right? By thinking this, what happens? Sai Ranga left. So see, it won't be very good for you are doing your graduation. You should have some basic ethics, right? You are attending numerical methods without calculator. How it would be better to attend numerical methods. Okay, Anshu, you unmute your mic.
Yes, sir.
Is you n2. Before that, you keep your decimal places into 4.
Sir,
Have you entered 2 and give equal to?
sir, today I only buy the new calculator, so I don't know how to use it. Can you please again tell me, like?
No, I have already detailed in some other classes.
Yes,
How many times I can repeat the same? Okay, are you having which type of calculator?
So today I buy the calculator of 991 ms.
Okay, at present you are having which serial number calculator?
Uh, 82 ms.
No issues. You can solve with 82 ms. I'll tell you. You put enter 2 and give equal to.
Okay, sir. Yes, sir. Done.
Okay, what is there with your screen?
So
2 alone or 2.0000?
2 point only.
Fix your decimal places into 4. There. Aravind Bosch.
Yes, sir.
Yes, are you ready, Aravind?
Yes, sir.
Yes. Aravind, give 2 and give enter, Aravind.
Yes, sir.
Yes, what is there with your screen?
2.40, sir.
Yes, very good. Then now give AC.
Okay, sir.
Give, okay, now this is what our results. Here I have instead to xn, we need to apply 2, right? Right.
Okay.
What I am trying to do, I am going to make the calculator options very easy with these simple calculations. We have given 2 as an information for calculator. I am going to make use of these datas with this information. See, give ANS
Yes, sir.
and then minus.
Okay, sir.
Give double open bracket,
Yes, sir.
double open bracket. Then have you did?
Yes, sir. Yes, sir. I have done.
Again give ANS and power 3, ANS power 3
Yes, sir.
minus ANS
-1.
minus 1
Yes, sir.
close bracket divided by
Yes.
open bracket
Yes, sir.
3
Yes, sir.
ANS square,
Yes, sir.
ANS square minus 1
Yes, sir.
close bracket, and then again give close bracket.
Yes, sir.
Right, now give equal to and tell me what is there with your screen.
1.5455, sir.
Very good, absolutely. That is what our first finding, that is x1 1.5455. Very good. Then now we can continue this iteration by using equal to alone, right?
Yes, sir.
What happened? The answer will be updated with 1.5455. Again press
1.3596, sir.
ways. Very good. The 1.3596. That is what your next result. Again give equal to.
1.3258, sir.
Very good. Again.
1.3247, sir.
Yes, that's all. That's all with these mathematical calculation. Little patience is essential since we are dealing with many factors. Patience is essentials. Then you give equal to
It's not changing, sir. It's same.
yes.
1.3247.
Yes, even after giving equal to with fifth time, you get the same result. That is 1.3247. So we can stop the iteration with the x4. So this is what the results. So thank you, uh, Arvind Bosch.
Yes, sir.
To use Newton-Rapson method to estimate the root of an equation, rearrange the equations into f of x. That too with the RHS would be 0. So differentiate that f of x one time and substitute f of x and f dash of x into the Newton-Rapson formula. That is xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So choose a substitute suitable choose a suitable starting value for x naught. So use these calculator techniques to find the results to iterate with the various informations. So by doing the proper usage of calculator can reduce your working time. So use this way to find the results, and this what the summary of Newton-Rapson method. So this is what your practice. This 2a. You please write. Use the Newton-Rapson method to estimate the root of the following equation with 6 decimal points using the starting value. So the f of x would be x cube plus 2x square minus 2 is equal to 0. Your starting value would be 1. So what happens when what happens if you use the x naught is equal to 0? So you first approach with x naught is equal to 1. Once your iterations are over, and then you approach with x naught is equal to 0 and try to find what happens with these newer data, and use your calculator or a graph plotter to sketch the graph. You please try to sketch the graph with these functions. And what is special about the graph at x naught is equal to 0, and why does it explain the answers to b? And you see something there with these problem and these informations, you come up the solutions, and I'll Arvind, you are you ready
Yes,
to
sir.
solve? Yes, Arvind, this is what your homework problem. Still we have some more time. You tell me the results.
Okay,
You
sir.
tell me the results. You now change the number of decimal into 6.
Okay, sir.
First of all, you change your number of decimal into 6. Others, you please make a note of this quotient. That is 2a and 3. Anyway, Arvind will tell the results. Arvind,
I'll do it,
yes,
sir.
yes, no. You tell me now. Tell me. You give 1 and give enter, and then answer minus what we need to do. And answer power 3 plus 2
Plus 2
answers,
into answer power square
2 answer
minus
square minus
minus
2 divided
divided
by
by 3 answer square plus 4 answer.
3 answer square plus 4. Yes,
Answer.
yes, yes, yes. What is our first iteration? That is what is our x1?
I'm doing it, sir. 1 minute.
Yes. Anyone, any others interested apart from Arvind? Anyone?
So I'm doing it, sir.
Yes, tell me, Siddhartha.
Sir,
Yes, Pranav.
first one it's coming 0.818182, sir.
No, Pranav. I think you need to refine.
Sir,
Yes.
sir, 0.857143, sir.
Yes, this is what the result. Very good, Dinesh. Pranav, you please try to cross check your calculations, and now give equal to Dinesh.
Yes, sir. 0.839545, sir.
No, 841165.
So no, sir. It's 0.839545 only, sir.
Arvind,
Yes, sir.
what was the second iteration result?
0.839545, sir.
Yes, I'll check and just a minute. The answer is 1, right? Okay. Answer minus answer power 3. 2 answers square minus 4 divided by 3 answers 3 answers square plus 4, right? Yes, there is an issue with my calculation. Answer, right? Right. The first what was the first iteration cell? 857143, right? Okay.
Yes, sir.
What was second
Yes, sir.
iteration cell? A39545.
Yes, sir.
Very good. Now tell me the third iteration cells.
83929.
9287. Very good, Siddharth. Then Pranav, what is the fourth iteration? 839287. Fourth iteration. Sir, tell me the fourth iteration.
Same, sir.
Wait. Pranav.
Yes, sir. I'm doing it again. I took x0 as 2 before that, so that's why I got it wrong.
Okay, you try. Yes, the third and fourth iterations are same. That is 0.839287. Now give AC. That is now give AC, and now give 0 and give equal to. Then your answers would be 0, right? Now go back to the past equation, and now you give equal to. What happens? Tell me.
So we can't divide by 0.
Yes, you'll get mathematical error, right?
Yes, sir.
Yes. So think about it and tell me, come up with these answers. That is A, B, C, D, and you even you please try to solve the problem number 3. Okay.
You have to
And how
factor
it can be?
So the
Yes.
denominator is 0.
Yes. The denominator is 0, right? What happened if the denominator is 0? What happened?
Sir, may I know the answers again?
Ismat, uh, for when x naught is equal to 1, you are seeking the answer, right? Ismat? Ismat.
Yes, sir. Yes, sir.
Yes, tell me,
Yes, sir.
Siddharth.
I want to know the answers, sir.
Yes, tell me, Siddharthan, what was the fourth iteration cells, Siddharthan? Your friend can recognize and cross check with his calculator results.
0.83929.
Are you getting the same results? Ismat?
I didn't change the decimal value, sir. Sorry, sir.
Okay, no issues. No issues. You try to change with six decimal places and try to get the results. And yes, how this problem 3 can be approached? Pranav, how this problem 3 can be solved with the Newton-Rapson method?
We have to take. Sir, 1 second.
That's a. Yes, you try to come up with these solutions. Okay, thank you. We will meet tomorrow 11:30. We will meet. Thank you. Any
Thank you,
doubts?
sir.
Sir, maybe
Any
we can
doubts?
use Taylor series.
Yes.
For
Yes, Pranav. Yes, Pranav.
maybe we can use Taylor series, and with that we can get it like a
Yes,
polynomial.
yes. We'll discuss. Any other doubts?
No, sir.
Okay. Okay. Tomorrow we'll meet during 11:30.
Thank you.
Thank you, sir.
Thank you, Ananda.
Thank you, sir.